Hi, my name is Christian. In today's video, I'm gonna present the first application that I have created to perform a fully reliability analysis using Python. If you consider this video relevant, then keep watching until the end. So let's get started. This is the primary window of the Reliability Toolkit. On this window, I can choose and select a file that contains all data, such as the time to failure and the write censored data. There are two types of file extensions allowed: Excel and CSV files. For this example, let me select an Excel file. Double-click and it is selected. Just to show how the data must be organized in the file, I'm gonna open up one file and share the contents. These are the information inside. The time to failure TTF must be placed on the first column and the write sensor data on the second one. So let's go back to the application. Here we are. After a file has been chosen, I'm able to determine which distribution best fits the data among the 5 most common distributions used for general reliability analysis. By clicking on the Calculate button, once I complete the test, it provides an illustration of the best fitted distribution based on the sum square year, and it is sorted in ascending order. There is no need to carry out the test prior to generating the distribution function's plot. However, it is very required if I literally don't know which distribution best fits my data. Moving on to the Settings button on the below side, I can open up the Settings window and change any parameters I desire in order to modify the calculation methods. All parameters already have a default value, but what if I want to change any of these ones and I don't know what does it mean? There is a menu on the top of the window where I can see the definition and explanation of each parameter. As an example, I'm gonna show the description of the heuristic constant. Here I have the definition and a brief explanation of the parameter and the possible values. Then now I can easily change anything. Firstly, let me set the confidence interval to 90%. Secondly, let me set the confidence bounds on reliability. The parameter estimation method I'll keep MLE due to the size of my sample and the amount of suspension data. But there are a few possibilities, like the least square and the rank regression. Optimizer I'll keep the same. Force beta is only applicable for variable 2 parameters. For sigma is only applicable for normal and log normal 2 parameters as well, and so on. That's all for now. Let me click on the button Save and Close to remain the changes made, and I'll be back to the primary window. Finally, the distribution functions can be plotted by selecting the distribution at first, and then on this window, I choose the type of the distribution such as exponential 1 or 2 parameters, as well as the desired functions: the cumulative distribution function, probability density function, survival or reliability function, hazard function, and cumulative hazard function. The probability plot is a simple visual way of summarizing reliability data by plotting the CDF function. So click on Create Plot button and the plot's going to be created. Obviously, from this point and on, a critical and deep analysis through each plotting is going to be essential, as well as to read and interpret the plots accordingly. And the last but not least, the original file has been converted to an executable extension. This incredible functionality allows the application runs in a machine without Python and all libraries installed. Well, that's all I have for this video. If you have any suggestions or feedbacks, just let me know in the comments. Thanks for watching.